My initial idea was to create a cloud solution for observability, not open source, just efficient cloud solution for observability. You need to open source VictoriaMetrics if you want to get high traction. The greatest feature of VictoriaMetrics is a very small feature, actually. It took literally a few lines of code in order compression of Prometheus remote write protocol. Prometheus can send switch to VictoriaLogs. Yeah, that's not joke.
Hey there, welcome to the Live on Production podcast by 1 to N. I'm your host Chinmay, and I would love to talk about all things engineering, especially cloud native. This is our first podcast, and we have a very special guest today, Aliaksandr Valialkin, who is the CTO at VictoriaMetrics, an open source, cost efficient observability solution. In today's episode, we are going to talk about building simple and reliable monitoring that scales and something that doesn't burn a hole in your pocket. Alexander, welcome to the show.
Hello, everybody. Thanks, Chinmay, for inviting me to this podcast. And I think that it should be a great podcast with great questions. And I hope I will give good answers to these questions.
All right. Yeah. Welcome. Awesome. So I want to kind of talk about the intro and your personal journey into the whole observability space, right? So to start with, I want to ask you like what led you to the idea of building VictoriaMetrics in the first place, right? Like back then, I think it's 2019, 18. That's the time you started. So what problems did you see with the existing monitoring solutions that led you to say, hey, I'm just not happy with how things are, and I want to build something on my own?
Yeah. I started VictoriaMetrics at 2018, and why I started VictoriaMetrics because before that I was a software engineer and I was working in different companies, and these companies were using different observability solutions. And the first observability solution which I met was Zabbix.
Interesting.
Yeah, and this solution looked great because before that I never seen any observability solutions, and I liked Zabbix could build graphs for different metrics over time, and that was awesome. But Zabbix had a single issue. The issue is that it was very hard to collect and custom metrics from your applications, to collect these metrics and to build some graphs from these metrics, to build some alerts from these metrics. This was very hard task to do because you need to write custom scripts for scraping, custom scripts for alerting, custom scripts for building this graphs, and it was and these scripts should be written for every metric you want to scrape. And this was not so convenient.
Yeah,
And
totally.
after that, my colleague Roman, he's another co-founder of VictoriaMetrics. He was working with me, and he discovered Prometheus. This was around 2016 or 2017. I didn't remember. And the Prometheus has been appeared recently, and this was a breath of fresh air compared to Zabbix, because Prometheus allowed you collecting arbitrary number of metrics, custom metrics from your applications effortlessly. You don't need to write special scripts for scraping every metric, for parsing it, for getting some useful information from it. And this was very great for us. We started using Prometheus, and in the half of a year, we met the first issues with Prometheus because we started putting a lot of metrics into Prometheus, a lot of custom metrics, and the amounts of these custom metrics grew over half a year from 0 to 300,000 metrics, as I remember.
Wow.
And Prometheus at that time wasn't capable to process this amounts of metrics, 300,000 active time series. This was Prometheus 1 point, I didn't remember which, no, not Prometheus 2 point. And the main issue was with disk I/O usage. Prometheus 1.x version was using a lot of disk I/O for these amounts of metrics, and it couldn't work good on even on SSD disks. So around the same time, we were working in the company which was providing advertising analytics, I would say, on large scale analytics. We were collecting requests, processing requests at the rate of multiple millions per second for this advertising analytics platform, and we tried to provide some good analytics from this requests, and we were using Postgres for collecting this analytics data, and then we're using custom scripts which we run on cron jobs for aggregating this collected large amounts of collected data into lower amounts of collected data. But this worked not so good. We tried scaling Prometheus horizontally. We tried different solutions at the time. We showed scaling Prometheus horizontally, but the solutions were hard to use and were not reliable. So we were seeking for different solutions, and around this time, again, Roman, my colleague, discovered ClickHouse, this
Yes.
analytical time series database. And we tried it, and it was again a breath of fresh air compared to Postgres for analytics
Yeah.
data, because it allowed us returning back from a big cluster of few tens of Postgres instances to a single node ClickHouse instance. And this single node ClickHouse instance was capable of processing much more data compared to this big cluster of ClickHouse or Postgres.
Postgres. Yeah.
Yeah, yeah. So I decided that I was excited with the capabilities of ClickHouse. I read how it achieved this high performance, high efficiency of storing data and processing this data. And I liked this idea. The idea was to process this data in column store and process the data in blocks which fit CPU caches. And I decided that it would be great to create a similar solution, but for observability and
Interesting.
similar efficiency.
Nice.
That's
Yeah.
how VictoriaMetrics has been appeared. So VictoriaMetrics uses the same ideas as ClickHouse for achieving high performance and high efficiency, high compression rate for data, and high performance for querying.
Interesting. So, I mean, you mentioned about your co-founder, right? Like you were. How did you guys meet? Did you know him before, or you met
Yeah,
at work or some conference?
VictoriaMetrics. At VictoriaMetrics, we have four co-founders, and I have met all these great guys before a long time before VictoriaMetrics has been started. I know them more than 10 years at least, and some of them I know more than 20 years. So, uh, and I met, they all are software engineers, and I met them at different companies where I was working before that.
Nice. Interesting. So, what came first, Victoria Metrics, the open source project, or the company? Like, how did you? What was the
Good question.
timelines like?
Yeah. Initially, my initial idea was to create a cloud solution for observability, not open source, uh, just efficient cloud solution for observability. I created the first version of this cloud solution and published it and we then were thinking how to promote this solution, and we had no enough marketing budgets for spending on promoting this solution at the time, and we had no any clients, and nobody know about our VictoriaMetrics, and nobody trusted us. Nobody trusted that VictoriaMetrics is capable to save you costs, and is capable to handle much bigger amounts of data compared to Prometheus or other observability solutions at the time. So we were thinking what to do next, and we met a great advisor. I also said that the advisor found us because
Right.
he heard about VictoriaMetrics and tried it, and found us, and said that guys, you need to open source VictoriaMetrics if you want to get higher
Community and good
traction.
adoption. Yeah, traction, right?
Yeah, that's how we open sourced Termit. Then we decided that it's great to open source it, and it was great decision. And after that, we saw steady growth of user base for Metrics, and users were happy. Uh,
Nice, nice. So,
using it.
yeah, interesting. So, I want to now talk a bit about the product, like the VictoriaMetrics product itself. So, some points, questions around that, right? But even you talked about open source, community traction, etc. Right? Still, there could be. I'm sure there are a few engineers who will probably not even heard about VictoriaMetrics. They're just starting their journey in the observability space, cloud native, etc. So if I'm an SRE and I've never heard of VictoriaMetrics, how would you describe this to me? Uh, yeah, like that's I
Mhm.
guess the
Mhm.
question.
This depends on whether you are familiar with observability solutions.
Yes.
If you
So
are,
correct.
if
Yeah.
you're familiar with observability solutions, then the task is easy. Uh, most of people know about Prometheus, for instance, and if you know about Prometheus, then VictoriaMetrics can be described as better Prometheus. That in two
Okay.
words. Why better? Because it is more resource efficient. It needs less amounts of memory, less amounts of disk space, less amounts of disk I/O, and also VictoriaMetrics is almost 100% backwards compatible with Prometheus. This means that you can switch Prometheus binary to VictoriaMetrics binary, and do minimal changes in your config, Prometheus config. Minimal changes which are related to alerting mostly, because you need VictoriaMetrics provides separate component for alerting, VM alert,
VM
and
alert.
this component understands Prometheus config for alerting, but you need to split alerting configs from scraping configs in Prometheus into two configs, and then use the same configs for VictoriaMetrics, and VictoriaMetrics can scrape, discover the same targets, and scrape the same targets in the same way as Prometheus does, and collect all the metrics. And also VictoriaMetrics provides an API compatible with Prometheus API, querying API, so you can continue using the same dashboards in Grafana and the same data source. You don't need to change the source. You need just change the URL in this data source from Prometheus URL to VictoriaMetrics URL, and everything should
Correct.
work as expected. There are some small incompatibilities in query language between Prometheus and VictoriaMetrics, but these incompatibilities are deliberate. These compatibilities solve real issues which user face when they use Prometheus. These issues are related to rate function, mostly to rate and to increase functions. And VictoriaMetrics solves these issues, and this breaks compatibility with Prometheus. And we don't want to return back these issues in order to be compatible with Prometheus.
Yeah. So in a way, it's kind of drop-in replacement, but with some better features and some and which require it to be incompatible in certain areas. Right? That way. Interesting.
Yeah.
So
And also another important point, VictoriaMetrics comes with two types: single node version and cluster version. And if you use Prometheus, you should know that Prometheus is a single node solution.
Yes.
It cannot scale horizontally. So if you reach the amounts of observability data which cannot be handled by single node Prometheus, then probably uh, you will search for horizontally scalable solutions. There are different solutions other than VictoriaMetrics. There is a Thanos, there is
Thanos.
a Cortex, there is a Grafana Mimir, there is M3DB, and you need to evaluate all the solutions and choose the solution which fits most to you. And if you use these solutions, try the solutions and try VictoriaMetrics, you will eventually will see that VictoriaMetrics is much easier to set up and operate compared to all these cluster solutions, Prometheus compatible cluster solutions. So that's the main feature why users choose cluster VictoriaMetrics compared to other clustering solutions for Prometheus. That's the main feature. And another feature is efficiency. VictoriaMetrics uses low amounts of memory compared to solutions and disk space also.
Interesting. So I have two questions related to feature. One is, what is a one feature in VictoriaMetrics that you are particularly proud of? Like, hey, this is a unique insight that which makes it very interesting to use for high scale use cases.
Yeah. uh, the most the greatest feature of VictoriaMetrics is a very small feature actually. It took a few lines of literally a few lines of code in order to implement it.
Okay.
But this I believe this feature is great, and it's strange that other Prometheus compatible solutions don't use this feature yet. This feature is related to data compression of Prometheus remote write protocol. Prometheus can send collected data to remote storage, and it uses custom Prometheus remote write protocol. This protocol is based just on protobuf messages, which are compressed with snappy compressor and then sent over network over HTTP. And Snappy compressor isn't so good at compressing data. It has not so good compression level. And what we decided that it would be great to replace this Snappy with ZSTD compressor. And this was great decision. It allowed reducing network bandwidth usage by 4 times on average, 4 or 5 times on average compared to Prometheus remote write protocol. Why it is important? Because if you run your services, you observe services which are located in cloud and send this data collected metrics to other clouds, you probably know about how expensive
Yeah.
data transfer for this
Correct.
data. And this feature from VictoriaMetrics allowed saving costs on this data transfer by 5 times. That I think that
Wow.
that's a
Yeah.
great feature because it's very small
Yeah.
in scope, but very big effect of
In terms
this
of
feature.
our, yeah, yeah, exactly. Yeah. And then related to that, what's the one feature you wish more people knew about VictoriaMetrics and used more?
What feature?
Yeah, like VictoriaMetrics has many features, right? So what is one feature that is least used, but
Listing.
you wish, hey, if people use this, or if they know
Yeah,
about it, or it could be just a small config change, but
yeah, yeah,
not many people go with that. They just go with default config,
yeah,
something
yeah.
like that.
Yeah, I would like that people use more uh, MetricsQL features. MetricsQL is a query language from VictoriaMetrics, which is compatible with PromQL most of the time, the query language from Prometheus. And it has many very useful extensions in practice compared to PromQL. And most users of VictoriaMetrics do not know about these features, and that's why they don't use these features. And I think that's most the main feature which has no the great feature which has no good traction, and we need to popularize using this feature. For instance, there are many small sub features in this MetricsQL language. For instance, MetricsQL allows using grouping some parts of query into
Mm.
templates. They are named with templates in VictoriaMetrics. And then you can reuse these parts of these queries, small queries or big queries, in first in the same query. So you can, for instance, you can calculate some um, result from some query, and then use this result, refer this result as just single variable name in different subqueries later. And this feature allows you reducing the repetitive usage of filters in or in PromQL or MetricsQL queries, because if you familiar with PromQL,
Yes.
you
Yeah.
maybe know that you need to duplicate all these filters across different series selectors which are used in the same query, because otherwise Prometheus isn't so efficient. It selects more data than needed and then filter all this data during queries. And this with template feature always solving this problem.
Nice.
Yeah,
Okay.
and another feature from MetricsQL is the ability to use OR filter in series filters. The Prometheus from QL doesn't support OR filter; it only supports AND filters. This means that if you
Mm.
write multiple filters inside curly braces, these filters are applied with AND
Yeah.
operation.
So it will reduce the data set
Yeah,
essentially.
and VictoriaMetrics supports also OR operator inside these curly braces. Nobody knows about this, but I think that it's a great feature.
Nice. Nice. Okay. Like in my experience, high cardinality is kind of the Achilles heel or weakness for most observability solutions, right? Like that's where all the roads kind of lead to high cardinality problems. So how does VictoriaMetrics handle high cardinality, both in terms of storage and during query?
VictoriaMetrics doesn't solve high cardinality issue at full, uh, but VictoriaMetrics tries optimizing code for reducing resource usage for high cardinality data. That's why VictoriaMetrics can handle uh, more active time series, more higher churn rate compared to competing solutions, and use lower amounts of memory, because
Mm.
high cardinality issue is mostly related to high memory usage, because you need to track all this active time series, high cardinality time series in memory, and this needs memory, obviously. And
Yes.
VictoriaMetrics just is optimized for using small amounts of memory for higher number of active time series. So on average, for instance, VictoriaMetrics can uh, process up from 5 to 10 times more active time series on the same amounts of memory compared to Prometheus or Mimir, Thanos. That's how it
Interesting.
solves it.
Yeah, yeah. So
And
it
both
kind of delays the problem a bit. Yeah.
querying time and data ingestion time. So, and
Interesting.
as for querying time, VictoriaMetrics also uses a great technique which was implemented at first in VictoriaMetrics and later it has been caught up with in Mimir, Thanos, and probably Prometheus right now. The technique is to parallelize data processing across all the available CPU cores during query time. This means that VictoriaMetrics always uses all the CPU cores at full
Correct.
when
Yeah.
you perform some heavy query. It unpacks all the data on all the available CPU cores and processes all this data on all the available CPU cores, and then merges the result and send you back. And this allows reducing wait time for heavy queries, and this also allows improving query performance by just migrating to the computer to the hardware with more CPU cores.
Interesting. And apart from monitoring observability, have you seen VictoriaMetrics being used for different other types of use cases? More analytical, but not related to observability or monitoring as a use case.
Yeah, some users try use VictoriaMetrics for financial data, for tracking financial data. That's not.
Yeah, so essentially time series, but not necessarily observability data, right? Like,
Yes, yes, yes.
fair enough. Yeah, makes sense.
Uh,
Interesting.
and another case. Uh, No, other cases are related to observability, but there are many types of observability. The most known observability type is IT observability of hardware, IT hardware, and applications. That's this type of observability used the most by the VictoriaMetrics users. But there are other types of observability, such as, for instance, observability of power plants, of
Yeah, sensors, IoT data,
yes,
that kind
IoT
of, right?
sensors, observability of space. I don't remember this word.
I think CERN uses VictoriaMetrics, so I'm guessing
Yeah,
they have some.
there are users which install VictoriaMetrics, so we imagined on spaceships and no, not
Wow,
spaceships. I didn't remember this word space. Just like spaceships, small spaceships,
right.
which collect some data in space and then send it to Earth
Ground station.
ground
Yeah.
station for storing and analysis. And they use VMagent, this separate component from VictoriaMetrics, which is needed for collecting data and forwarding this data to remote storage. And this VMagent is installed basically on these spaceships and sends this data to ground stations when there is a network connection with ground stations, because in space you don't always have good connection with the ground.
Correct. Yeah, and even the fact that you mentioned it can compress, like the compression and sending the data. If there is good compression, then that's also going to be super useful there.
Yeah.
Interesting. Uh, I have a question more on the either like on the architecture side or you know being able to operate it at some scale, right? So inherently stateful systems are very hard to scale. VictoriaMetrics being a database, ultimately, like how do you make it scalable horizontally? Like how can I? What are some key decisions from architecture point of view that make it easy to scale horizontally?
Yeah, VictoriaMetrics is old-fashioned in this space in horizontal scalability. It uses uh, it scales horizontally across multiple nodes, and it has three types of nodes in cluster version. When select, this node is used for processing queries. When insert, these nodes are used for accepting data and then routing this data to when storage nodes. And all these three types of nodes can scale independently and can run on different configuration hardware with different configuration. And VM select and VM insert nodes are stateless. This means that you can scale up and scale down them
Yeah.
whenever you want. And VM storage nodes are stateful, and they store data locally on local disk. That may sound not so sexy compared to the same Tanas or Mir, which store data on object storage, which sounds more sexy. But in
Yeah.
reality, VictoriaMetrics approach works quite good. Our users and customers can prove this, and it usually works better than the approach with object storage, because local disks are usually much faster. They have much
Correct.
lower latency, IO
Latency. Yeah.
latency compared to network object storage. This latency is milliseconds versus hundreds of milliseconds compared to object storage, 100 times difference. And this allows improving query performance a lot, especially for queries over historical data when you need to read this data from disk instead of reading this data from cached object page cache operating system. Yeah,
Interesting.
and users usually say that object storage is much cheaper than persistent disk, local persistent disk. That's a good argument, but in reality, VictoriaMetrics is optimized for HDD disks. There is no need to use SSD disks. It uses as low number of I/O as
Random IO.
operations as possible. So it works quite great on ordinary HDD disks, and HDD disks in clouds are not so expensive compared to object storage. They are only twice expensive, usually twice expensive than object storage, but you get much higher performance, and also VictoriaMetrics compresses data much better, also 3-4 times better than Prometheus on average. So in the
You
end,
can
you
store more. Yeah.
save costs, not pay less than more compared to object storage.
Mm,
Yeah.
interesting.
And yeah, there is an inconvenience that you need to manually manage this storage
Mm.
nodes, manually manage these persistent volumes, manually increase the size of these persistent volumes when needed, or manually add additional storage nodes. But that's traditional
Yeah.
operations tasks, which are not so hard to do and easy to understand and easy to debug if something goes wrong.
Yeah. I think simplicity and then predictability of infra then becomes much more easier then. Something on open source side, I didn't touch upon your reasons for open sourcing it. So could you talk maybe more on why you decided to open source VictoriaMetrics, mainly from, like you spoke about, mainly from traction and that point of view. Now it's been 4, 5, 6 years, close to that, right? Since you started. How do you see that community support? Do you see, how do you accept community contributions on open source? What's that workflow like right now?
Yeah, we are very glad that we go open source way because not because the main reason was that gaining high traction, but we see that this helped a lot evolving VictoriaMetrics in the right direction because we users start using VictoriaMetrics and they have different use cases and they have different ideas how to improve VictoriaMetrics. They can file feature requests, found bugs in VictoriaMetrics, and this allows us deciding, helps us deciding what to do next in VictoriaMetrics, and that's great because we grow organically and we implement
Yeah.
features which are most important to most of the users of VictoriaMetrics, and this works great. And this also allows us increasing coverage of different use cases for VictoriaMetrics. And improving the quality of code over time because different use cases found different edge case bugs, and we can fix these bugs. If VictoriaMetrics was closed source, then the number of users, active users of VictoriaMetrics, would
Yeah,
be much
limited.
smaller, and they couldn't discover all these edge cases. Uh, this
Nice,
In this
interesting.
case, VictoriaMetrics was not so good from bug-free point of view.
No, makes
And
sense totally.
we see that users also help us improving documentation in VictoriaMetrics. We publish all the documentation in the same repository as VictoriaMetrics, and uh, it's great that we see that users help fixing typos and improving documentation. And we also see that users send us pull requests for bug fixes or feature for implementing some features. That's also great. And the amounts of these pull requests grow over time, and that's also great. But from another side, right now we stumbled with another issue that the number of such pull requests is so high that we cannot keep up with reviewing all these pull requests. Uh, and we are thinking right now what to do, how to solve this issue. And another issue is that the number of feature requests from users also is much bigger compared to what we can implement and what we want to, no, not I would say
Mm.
what VictoriaMetrics needs to be implemented. Because if
Correct.
we implement all these features which users want, then VictoriaMetrics eventually will become very bloated, like
Yeah.
most of the software, and this bloat will slow down VictoriaMetrics, will make harder to add essential features to VictoriaMetrics,
Mm.
and this bloat also usually leads to high number of bugs, edge case bugs, which grow exponentially with the number of these added features. So the hardest task right now for us is to uh, prioritize all these features and to decide which features should be implemented first and which features should wait or should be closed because they go against the spirit of VictoriaMetrics.
Yeah, and I think all projects, as they get adopted more and more, face this conundrum, right? If you implement everything, then it's going to just bloat up and it's going to slow down, and the core of what the product or software is about, that will be lost in some way, right? That's, I think, one of the hard problems. So I want to talk more on the now company side. Company VictoriaMetrics as a company, like let's start with like how do you get your first customer, big logo customer? What was the journey like?
Yeah, the first paying customer has been appeared in VictoriaMetrics after half a year from the first release of VictoriaMetrics Cloud. The initial
Wow.
release of VictoriaMetrics Cloud was at 2018 at the autumn, and this customer has been appeared on the in spring 2019. Yeah. Uh, and this and we didn't open source VictoriaMetrics at the time yet. We open sourced it only in May of 2019, as I remember. So this customer just reached us before the open sourcing because he read about VictoriaMetrics in some news and tried it. Before that, he was using Prometheus and he tried VictoriaMetrics. He discovered that we don't lie in our
Yeah.
release notes, that VictoriaMetrics is resource efficient and fast. So he decided that it would be great to reach us and pay us for technical guidance, technical support of the installation of VictoriaMetrics. That's how our first paying customer has been
Interesting.
appeared.
Nice. Yeah, I think marketing and the real documentation, and there's not much disparity, definitely. So how does VictoriaMetrics as an org operate, right? Like the engineering quality, the outcome is phenomenal, is outstanding, right? So I'm curious, what motivates the team, or how do you keep the team focused on what to build?
How we keep focused on what?
Yeah, how does a team know and focus on what to build? How do you run this as an engineering organization? Now we are talking beyond a single person or a set of very small set of people. Like how do you run engineering org as a function, and hey, prioritize open source,
Mhm.
then commercial features, being
Mhm.
able to do 100 other things apart from coding.
Mhm.
It's kind of all blended in, right? So how does org work as a uh, how does the organization work right now from an engineering point of view?
Right now, VictoriaMetrics is around 30 people, contains 30 uh, coworkers, and around 10 of them are software engineers, and others are different sales, support, marketing team. legal stuff, and so on. Managers, and I would say that we grow organically. We didn't get yet any VC money, and this gave us good freedom in decisions which we can make, and decisions in which we can evolve company. So we grew organically. Initially, there were four co-founders, and after that, we started hiring additional people in the company. And after that, we felt that we need to add additional bureaucracy to the company. I mean, making this hierarchy in the company.
Yeah.
Managers hierarchy, and right now we are in the process of transformation of the company from flat company to hierarchical company. There are some managers who are responsible for feature prioritization for open source. There are the people who are responsible for cloud version of VictoriaMetrics. By the way, we returned back to the cloud version. Our initial cloud version has been stopped after we open sourced VictoriaMetrics because we had no costs for keeping it running. And we had no any customer on this cloud. And recently, a year ago or a year and a half ago, we released VictoriaMetrics Cloud again. And right now we have a separate team which work on this cloud, and it also gains good customers, and the cloud part of VictoriaMetrics grows. So we just grow organically and hire
Right.
additional
Right.
people and hire additional managers or promote managers from our existing coworkers when we feel the need for this. And that's
Interesting.
how we
No,
work. And the interesting thing that we have no, the most of our customers pay us for technical support. And
mm,
this may sound that we need to have a large team of customer success team, but we have
correct.
no dedicated customer success team because we initially we tried organizing this customer success team. We tried hiring customer support folks, but this didn't work well because most of our questions from our customers are very highly technical, and these
Technical.
questions
Yeah.
need to know VictoriaMetrics code, need to be able to debug this code in order to answer the questions from this customer, need to be able to fix some bugs, to be able to implement some features. That's why we end up right now with the support, which is provided by our engineering team, our engineers
Mm,
at VictoriaMetrics. So that's how we provide
yeah.
support. And customers are very happy with this because compared to an average vendor which provides technical support, VictoriaMetrics is much, much better in this technical support compared to other companies.
Correct. Interesting. Because yeah, the solutions are very technical, and even the use cases are very very specific technical. So requires more in-depth knowledge of Victoriametrics, and then who better to communicate that or talk about it than the engineers who built it themselves. Interesting. So then, more a question on the hiring of engineers, right? Like how do you hire talent? Like what do you look for in an engineer? What's your hiring process?
Mhm. Good question. We hire engineers organic. Let's say we don't use some external HR agencies. We just post our text of our vacancies in our channels, VictoriaMetrics channels. I mean, Slack chat, Telegram chat,
Yes.
on Twitter, LinkedIn, and many software engineers want to work in VictoriaMetrics because that's a great work compared to an average company, and we have good work conditions here. That's why it's not so hard to hire engineers. Also, I noticed that most of our engineers were working with VictoriaMetrics before they became our engineers. That's great because we don't need to spend time on teaching these new engineers in VictoriaMetrics specifics. Uh, and this also means that these engineers already had experience with VictoriaMetrics, and they were already liked VictoriaMetrics, because otherwise they wouldn't apply to VictoriaMetrics. And this is also great for us to be able to hire these engineers from our communities, for VictoriaMetrics
Nice.
communities. I mean,
Yeah, yeah. I think open source communities have that kind of network effect, right? Where if I'm already using a product and I see an opening at the company where I like the product myself, I would jump at it and say, hey, can I work with you guys? I have more ideas from my side that I want to contribute. And yeah, that's really the best part about open source.
yeah.
Cool. So, from a day-to-day perspective, what does your typical day look like at VictoriaMetrics? Like, how do you manage your time in coding versus any other activities, that you have to perform as a CTO?
Mhm. I am very happy with to work with Metrics, because uh, my typical day is to work uh, more than a half day on coding, on code tasks, on reviewing others' work, on deciding what to do next, on thinking on some architecture questions. Uh, and another low no, amount of day. I mean, 20% or 30% of day, as working day, is spent on some communications with
Mm.
colleagues on different questions of VictoriaMetrics. Yeah, that's great, because I'm not involved into management too much, because I don't like management. I like coding and I like technical tasks, and I have good possibility to do what I want, because other colleagues take over this management tasks for me.
Yes.
That's great. Thanks for
Nice.
my colleagues' hard work.
Yeah, no, that's really good because I think I was checking. You have the highest contributions in VictoriaMetrics and continue to contribute daily on it. It's just insane to see. You know, you're able to like manage both right now. So that's really a great thing to see. So throughout your journey, right, of being in the observability space, I want to understand what have you seen change or evolve from where you were in 2018 when you worked with Prometheus to now and even beyond, right? What tools, methodology, thought process, what has changed, what has remained the same? And kind of related to that is how the whole Gen AI and LLMs and the whole AI space, how do you see that merge with observability in general?
Mhm. I see that big trend in observability space right now is open telemetry. Uh,
Yes.
yeah, the open telemetry idea is great to provide observability solution which covers everything, and which satisfies everybody. Uh, but that's goals are great, but the implementation is not so great usually. Right now, OpenTelemetry provides three stable observability types: with traces, metrics, and logs. And I don't know anything about traces, because we don't touch traces yet. But open telemetry for metrics isn't so good. Our users wanted integration with open telemetry protocols, so we had to add these protocols to VictoriaMetrics, and that was not so joyful journey. I'd say, uh, because the official SDK for OpenTelemetry for Go was and probably is, I would say, too bloated. That's not so good word, but that's reality. Uh, for instance, the build size of VictoriaMetrics, the final size of VictoriaMetrics executable, is less than 20 megabytes. And when we tried adding OpenTelemetry protocol to VictoriaMetrics, just using this official OpenTelemetry library, this increased the size of VictoriaMetrics to more than 30 megabytes. This means to more than 50% just
Yeah.
for additional protocol. VictoriaMetrics, by the way, VictoriaMetrics supports many different popular data ingestion protocols other than OpenTelemetry, and the implementation for these protocols usually increased binary size by maximum 10 kilobytes, not 10
Mm.
megabytes. That
Yes. Yeah.
was strange situation that slowed down adding OpenTelemetry support into VictoriaMetrics, and eventually we had to re-implement this OpenTelemetry
Mm.
specification for metrics in VictoriaMetrics source code. Don't use this OpenTelemetry official SDK, and this allowed us reducing this binary bloat a
Mm.
lot by a few tens of kilobytes. But the protocol for metrics itself for OpenTelemetry isn't efficient. It
Mm.
contains very mm, big amounts of different fields, different properties, and so on, which aren't used mostly all the time in
Mm.
observability space. And we had to add all this support for all this stuff because it's protocol, OpenTelemetry protocol for metrics, and this slows down data ingestion, data parsing, and this also increases the amounts of data which should be transferred over network for OpenTelemetry protocol. And for instance, if you compare OpenTelemetry protocol to Prometheus remote write protocol, then Prometheus remote write protocol is much simpler to implement, to handle, and it also uses lower amounts of network bandwidth compared to OpenTelemetry protocol for metrics. That's the issue, but I believe that it will be resolved eventually. Recently, we started adding OpenTelemetry support for logs. By the way, VictoriaMetrics
VictoriaLogs.
started working on VictoriaLogs
Yeah.
solutions, so this solution for logs, and we started investigating whether it's possible to add OpenTelemetry for logs into VictoriaLogs, and it has been appeared that this protocol for logs from OpenTelemetry is much better compared to OpenTelemetry protocol for metrics.
Metrics.
It fits almost easily to the concepts of VictoriaLogs, stream concepts of VictoriaLogs, and that's great. So not so that's the recent trends which I see in observability space. Everybody wants using OpenTelemetry, and probably that will give us a good outcome because this will simplify changing vendors, changing your solutions, observability solutions, without the need to switch in different protocols. But let's see how it will go. As for ChatGPT, LLMs usage in observability space, there are VictoriaMetrics doesn't use ChatGPT and LLMs right now in any way because I don't see any good applicability cases. The only applicability case which probably will work great is documentation assistant for VictoriaMetrics.
Mm.
Users, I would say it can replace substitute the first level of technical support, which we have no
Yeah.
right now. But uh, we can replace this first level of technical support. So this chat GPT. And it works right now. This new search engine, which is named Perplexity.
Perplexity. Yeah.
Perplexity, yeah. And I tried asking this search engine typical questions which users ask about VictoriaMetrics, and I like how it give answers for these questions. Contrary to canonical ChatGPT, the Perplexity continuously scans all the new contents on the network on the internet, like Google does, and
Correct.
uses this content in its answers, and it does good job for answering typical questions, not so hard questions about VictoriaMetrics usage, about VictoriaMetrics different use cases, and so on, and that's great. This works great because it's indexed all the documentation of VictoriaMetrics, which is public, and it uh, all is able to provide good information, good answer from this all the documentation. That's great, and I think that the way which can be used in the future by VictoriaMetrics users in order to search for their not
Interesting.
so
Yeah.
hard questions about VictoriaMetrics.
Yeah. Of course. Yeah. But at least it can take care of the typical questions that can be answered easily, right?
Yeah, it works much better than Google in this case, because Google
Right.
provides you some links to this documentation, and after that you need to click on this link and then search for over big documentation for the particular information. And Perplexity just provides you a concrete answer to this question, and that's great.
Yeah, interesting. So now I want to move on the organizations, like this part where how do organizations should implement observability, right? Like more uh, from your lens, you've seen various use cases, customers using VictoriaMetrics and also other products to be able to implement observability, monitoring, logging solutions, right? So let me start with something like this, right? What advice would you give an engineering team working in an org that doesn't have any observability setup right now? Like we are running on production with some infrastructure and some services, but we haven't invested at all on observability. What are some things, some basics that we should get right before we start thinking, scale or even higher problems, right? So what are some basics to get right which you think people often miss and they run after the shiny fancy stuff?
Yeah. The basics right now is observability basics right now is to install node exporter on every host which you have. Uh, the node exporter who doesn't know is this typical Prometheus exporter, typical Prometheus component, which runs as a single binary, and it collects some metrics and exposes them in clear text at some web page, which Prometheus can then scrape. And node exporter is the essential component. I believe it's the essential component for observability because it collects metrics, hardware metrics, metrics related to CPU usage, memory usage, network usage, disk I/O usage, disk space usage, and so on. You just install this small binary on every host you have and collect metrics from with Prometheus or with VictoriaMetrics or with other solution, and you instantly get observability, good observability, quite good observability across all your hardware, across all your hosts. That's the first step I would say everybody should do when they start diving into observability space. Yeah. After that,
But
I would suggest searching for Prometheus exporters for applications which you use in, For instance, if you use Postgres, there is a Postgres exporter. If you use Nginx, there is an Nginx exporter. If you use other components, there are exporters for almost every component. And this allows improving observability for all these components and allows making allows improving observability and allows also setting up alerting on this on metrics which are exposed by these components, and this improves the operations, let's say, of the company. May save a
Right.
lot of efforts and time for instance, if you see that some resources, hardware resources, become scarce, for instance, CPU and memory, over time, then according to observability provided by Prometheus and node exporter, then you can plan ahead, expanding, adding new resources instead of uh, instead of saying that's fine when everything is under fire.
Yeah, 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 yeah. So more early warnings in some way, right? Like you see the disk fill up more. Typically, I've seen for database instances, in most cases, people don't even have basic disk monitoring, and the writes start failing, and then you come to know, oh, we've got a full disk, and that's kind of a very simple rookie mistake of sorts. Uh, uh, on what matters more in observability, right? Say you've got metrics, you've traces, and you've logs, and there is events as well. For example, how should teams think about these? Like, what priority order should I give to? Should I worry about metrics first? Should I focus on logs? How do I, as a company, decide what matters most? Like, and this is from the point of view of debuggability. This is from the point of view of being able to manage observability stack itself myself. From all of these points, even cloud cost point of view, how
Mhm.
should orgs think about these?
Yeah, good question. I believe that the most important part of observability is alerts on metrics. This means that everything should start with alerting, properly set up alerting rules for components and parts of your system which are essential for your business. Uh, and if you see that some alert fires, then after that you need to go to dashboards, to metrics, and see investigate graphs for related metrics to this alert. And after that, probably you need to go to logs around the same time when this alert started triggering, and to logs on which are exposed by components which trigger these alerts. And the last resort is traces. And I think that traces are overhyped in observability right now. They are most expensive observability ish, observability item. I would say they need they generate usually a lot of traffic, a lot of CPU usage, disk space usage compared to metrics and even logs. And they provide, while they can provide very useful information, very fine-grained information about what was going on in the system at a particular time. That I I think that that's not comparable price to this functionality. So you pay much more for this observability, for the ability to investigate, fine grain, investigate what's going on at some time in the past. Uh, and I think that's overhyped traces right now. As for logs, I think that logs are very useful, like metrics too. Logs can generate much more data than metrics. Logs can help you understand what was going on in the system at particular time if the login is implemented properly.
Correct. Interesting. And related to that, people always want or look for, hey, I should be able to get to a metric, find out that time window, be able to see the logs, essentially correlate metrics, logs, traces, events, all of them in one single observability pane, right? Single pane of glass.
Yeah.
Practically, from your point of view, how do you think, is this genuinely useful, or is it again sort of marketing hype that yeah, you need a single pane of glass? What has been your
Yeah.
practical experience?
I think that this sounds very good single pane of glass of all the observability metrics, logs, and traces on the same dashboard. Sounds very good, and people like this idea when they hear it first. But from my experience, it doesn't work well. Even, for instance, not recently, a few years ago, Prometheus developers added exemplars into Prometheus. This new type of additional type of labels with value, which can be attached to every metric which Prometheus exporters expose. And um, this allowed improving this correlation between logs, traces, and metrics, because you could put trace ID or log ID or other information into this exemplar labels with some actual value of the metric for this exemplar, and put all this information into this exemplar. So later, Prometheus scrapes this exemplar and provides an API for querying exemplars for particular time series, which it was scraping. And Grafana is able to provide integration, this correlation between metrics and
Yeah,
logs. When you look at the graph of a metric which exposes these exemplars, you can click on dots for these exemplars,
go to
particular
that
metrics,
particular.
and
Mm.
then instantly jump to traces or to logs according to the labels of these exemplars. That's the demo works great, but we recently tried it. In one of our internal services, and it wasn't so great because of different issues. The first
Mm.
issue is that these exemplars are supported right now only are supported by the official Prometheus library, Go library for exporting metrics, uh, only for histograms. There are different
Ah,
types of metrics in Prometheus:
yeah,
histograms, summaries, counters, and gauges.
gauge. Yeah,
And only histograms support these observability exemplars.
exemplars.
That's the first issue. The second issue is that it is not very trivial to implement in code exposing custom exemplars on your histograms using this official library from Prometheus. That's a very, very non-trivial task. Uh,
Mm.
that's why I see that exemplars didn't gain big traction
Traction. Mhm.
over 2 years since they have been appeared, because of the complexity of implementing it or using it. And another issue, when even if after we implemented this exposing these exemplars in our application, uh, it was unusable to use to jump between metrics and logs in Grafana, because usually these exemplars are exposed on Prometheus histogram buckets,
Mm.
and usually there are many buckets. I would say that thousands or even million buckets of some metric are exposed across different applications, across different instances of the same application. And you usually build some graph which shows some quantity over all these thousands or millions of buckets.
Mm.
And every bucket exposes its own exemplar. And this means that when you
Just
look at this graph,
explodes in, yeah.
look at this graph, every timestamp on this graph contains literally thousands and millions of dots, and
Wow.
this completely breaks Grafana. It
Unusable, yeah.
stops working, and it is unclear how to work with all this stuff.
Interesting,
So that's
interesting.
great. The great idea, exemplars, I believe, are a great idea, but not so great implementation. And I think that this problem of this correlation between metrics, logs, and traces is not so big because it usually metrics already contain labels which are uniquely identify particular instance of the application. And if this application exposes some logs and traces, it is much saner and easier to attach the same labels for unique identification of this application for logs and traces, and use these labels for correlation. For instance, you look at the graph, you see some anomaly on some time range for some metric for some instance, and then you can instantly open another tab with logs and
Yeah,
traces on the same time range with the same for the same instance and see what was going on in this instance. And you don't need this hard to implement and use uh, exemplars.
correct. Yeah. So maybe just go good old fashioned way. Look at the kind of labels you have. Open the same labels for whatever type you need, like logs or traces, uh, during the same time window. Right? They just saving you one from one click in some way. Interesting. So, if there is a CTO or a VP of engineering or a director who's listening to this, and uh, they are they are thinking of whether I should go build or whether I should go buy mode, so build versus buy for their observability solutions, how would you suggest they think about the build versus buy part of it?
Good question. I would say that initially, if you just started this observability journey, uh, it is better to buy some vendor solution because you are not familiar with this observability space, and uh, you have usually have no enough resources, enough people who know how to manage all these
Set it up, yeah.
observability solutions. And from this point of view, it's better to buy some third-party observability solution and use it until your bill for these observability solutions become too big. And after that, it's time to build your own observability solution. That's
Right.
how most of our users and customers end up with
Switch to VictoriaMetrics. Okay.
VictoriaMetrics.
Right. So, what's the? I mean, related to that, right? Then, what's the cost I should think about? Like I've on Twitter or some other places I've seen. Oh, my cloud costs are $1 million a year or a month, whatever, and my cost for running the observability solutions is say 25-30% of my overall cloud cost. What's the ballpark, or how should I think about these costs? At what point should I make a decision? I know it's again nuanced and there is a lot of caveats, but at a high level, do you have any rule of thumb that, hey, you should,
Mhm.
if you're having like 50% of your cost goes into observability, probably that's too high. If it's less than 5%, maybe that's too low. Like, how,
Yeah,
how should I think about
yeah.
this in terms
I
of
think
my
that
overall cloud cost?
yeah,
Yeah.
it's better to think not in percents of costs, but it is better to think in absolute values, absolute numbers. And I think
Got
that
it.
it is good idea to start thinking about switching from some vendor observability solution to in-house observability solution when its costs became bigger than salary of full-time employer, DevOps employer for year, for instance, per year.
Got it.
And if it exceeds this number, then it probably it's time to
Reconsider. Yeah.
build
Think.
own
Yeah.
observability solution.
Interesting. Correct. Correct. So let's quickly talk about the scale part of it, right? Like, what are some largest and highest volume deployments of VictoriaMetrics? What size and rate of metrics ingestion are we talking when we say scale?
Mhm, mhm,
Just to for people to get an idea of what is even capable with VictoriaMetrics.
mhm, mhm. Uh, the most largest large scale solution which is built on VictoriaMetrics uh, is located in China. Uh, uh, we have no customers yet, as I remember, in China, but we have a lot of users in China and a lot of users with large scale setups of VictoriaMetrics. These users frequently ask questions on our Slack chat or GitHub issues. And as I remember, there was a user who was saying that the data ingestion rate was around billion of samples per second in his VictoriaMetrics cluster. That billion per second.
Wow.
That's a production cluster, not just testing. And
Correct.
that was great. And as for the number of active time series, I don't know. I didn't remember, but I can say that we have customers with the ingestion rates at around 20, 50 million of active time series per second. Oh, no, not active. 20, 50 millions of samples per second, and the number of
So
active time series is more than a billion. We have such customers with contracts, support contracts.
interesting.
Uh,
So
And,
for
and
these,
by the way,
hmm,
we have many customers, and some of these customers agree to provide case studies for them, and we have these case studies on our website.
yeah,
And
I'll link up with them
yeah,
later. I
and
see a
there
lot
is
of
a
case
case
studies.
study, good case study from Roblox. Yeah, yeah, there is a good case
Hmm,
study from Roblox, and they have you can read it. They have 5 billion active time series and 120 million data points per second ingestion rate, for instance, from the
interesting.
telemetry.
And then this gets me to the question that where VictoriaMetrics has two modes of operation, right? One is your single binary single node version, and other is my cluster version. Again, I have seen the docs. The recommendation is to probably go with a single node version to start with. But again, what's the rule of thumb I should think? At what point should I really think about going with a cluster version? And even if I'm going with a single binary version right now, how do I think about high availability for that setup itself?
Mhm. Uh, the high availability of setup for single node version of VictoriaMetrics is the same as high availability setup for Prometheus. You just install two identically configured Prometheus or VictoriaMetrics instances, and these instances scrape the same data, the same targets, and store the same data locally. And then you can set up a separate proxy
Proxy,
uh,
yeah.
yeah, which is able to scrape both Prometheus or VictoriaMetrics instances and then merge results and return you back results. That's the way how high availability can be implemented in single node version of VictoriaMetrics. But compared to Prometheus, Prometheus has not so good history of recovering uh,
Hmm,
from crashes or from restarts uh, because of write ahead lock. Uh, uh,
right.
and I don't know whether this write ahead lock isn't implemented properly in Prometheus or why, but users of Prometheus usually complain that uh, Prometheus may restart for literally hours after some crash or after just restart upgrade. because of this write-ahead lock. And eventually, they had to just drop this write-ahead lock and restart Prometheus and lose a lot of data
Lose some
which was
data.
stored in this write-ahead lock. And VictoriaMetrics doesn't have this write-ahead lock. It just stores data directly from memory to uh, to disks, persistent storage. Yeah, it can lose, actually it can lose a few seconds of data on crash, because this data isn't persisted yet from in memory to disk. But on the other hand, the restart times of VictoriaMetrics is literally a few seconds. So even if VictoriaMetrics crashes because of some out of memory errors or some bugs, it recovers in seconds, and you lose just a few seconds of data. And that's also plays big role in high availability systems built on top of VictoriaMetrics or Prometheus. And your question, second question was when it's time to switch from single node version of VictoriaMetrics to cluster version of VictoriaMetrics.
Yeah.
I think that you need to switch to cluster version of VictoriaMetrics when you see that a single node of VictoriaMetrics cannot keep up with your amounts of observability data and queries you issue to the system. By the way, we have a client again which provided us case study, but we didn't update it recently for a long time. And this client continues using a single node of VictoriaMetrics. This client is Wix.com. Uh, he continues using a single node of VictoriaMetrics at the scale of around 100 millions of active time series, and the data ingestion exceeds 1 million of data points per second, with a retention period of 3 months or half a year, 3 months. So you can read this case study on the website and understand how capable of single node of VictoriaMetrics to scale.
Yeah, pretty interesting. So we can continue to vertically scale it as much as possible, and until we feel comfortable that, hey, I think at this point I need to invest in a proper horizontal setup. That's the time to kind of think of a
Yeah,
switch.
yeah.
Makes sense. Uh,
Why I think
so
so? Because single node version is much easier to set up and operate compared to cluster
exactly
version. Obviously, because single node version is just a single binary with minimal configuration. You just start it and it works. And cluster version contains three types of components, and you need to
correct.
provide different configuration to every component, decide how many every component instances should run, and this is not so easy. But if you use Kubernetes, and like most people do right now, uh, uh, it greatly simplifies running cluster version of VictoriaMetrics, because VictoriaMetrics provides Helm charts and operator for running simplifying managing of cluster version of VictoriaMetrics in Kubernetes. And
Yeah,
many people just start with this Helm charts and operator for VictoriaMetrics, and don't mind about single node version of VictoriaMetrics, even if they have pretty low lot and amounts of
got it.
data.
Yeah, so getting started with a Helm chart or a operator just becomes much more easier then. Yeah, makes sense. So I think one last question on the scale part. What's the most common mistake have you seen orgs make in implementing observability? It could be something like they think is right at that point. They think, yeah, I need this data or I need this thing, but at scale they can't think how it will fail, and it fails at the scale, at certain scale.
Mhm.
What are some insights, or have you seen something like this?
Yeah. Let's talk. I will talk about two cases,
Yeah.
which most common cases, common errors which people make when they set up observability. The first case is to collect too much metrics, too many metrics,
Yes,
because
I've seen that. Yeah.
this case. usually appears in Kubernetes monitoring, because in Kubernetes components expose a lot of metrics, and
Yeah.
default configuration for uh, observability in Kubernetes is set up to scrape all these metrics, and you end up with
Tons
a
of,
lot of
yeah.
metrics, and
Yeah.
uh, you need to dedicate a lot of resources to CPU, memory, and disk space for monitor of observability. And in the end, you just use only a small fraction of all this collected data for your
Mm.
observability tasks. And that's the first error which I see frequently in observability. And the second error is uh, pushing. There are two types of of two methods of collecting metrics in observability. It's push and pull. Push,
Push and pull.
if your application just pushes some metrics to centralized solution, observability solution. And the pull method is if the centralized observability solution scrapes these metrics from the applications. And Prometheus is a pull-based system, and VictoriaMetrics supports both pull and push
Both. Yeah.
protocols. And people who use push protocols, they usually make a common error, which is related to pushing too much samples to VictoriaMetrics. They just, for instance, if they implement application which serves some external requests at high rate, 100,000 requests per second, and sometimes the developers of this system decide that it's a good idea to post a single metric or multiple metrics per every request to a centralized system. So you end up with thousands of metrics per second from a single instance of your application. And
Mm.
that's an incorrect way to push observability data to the system. And the correct way is to use some statsd like application to push metrics to statsd like application, or to be imagined with stream aggregation enabled. And this intermediate application should aggregate these metrics and reduce the amounts of these metrics to much smaller number, and regularly push these metrics at regular intervals to centralize the system. And the amounts of these systems follow reducing the amounts of metrics which sent to VictoriaMetrics or other observability system by literally by millions of times without losing any observability capabilities.
Interesting. Right. So I think I want to conclude by asking you a couple of rapid fire questions. These are, very like one liner answers for some of them essentially. And then I think we will conclude the discussion. So one is, if you can only say one line to a VP of a company who's struggling to manage and scale Elasticsearch, what would you tell them?
Switch to
One
VictoriaLogs.
line.
Yeah,
Interesting.
that's not joke, because we conducted benchmarks between Elasticsearch and VictoriaLogs, and this benchmark showed that VictoriaLogs needs up to 30 times less memory compared to Elasticsearch, and up to 10 times more disk space compared to Elasticsearch, and
Wow.
without losing in query performance a lot. Obviously, there are some queries which perform at slower times, but there are some queries which perform better. But on average, you just VictoriaLogs switching to from Elasticsearch to VictoriaLogs allows you saving uh, more than multiple of order of magnitude costs for memory
Yeah.
and disk space.
Interesting. Uh, in one word, describe to me what's your take on the current state of OpenTelemetry.
What one opinion?
In one word, can you
What
describe the current state of OpenTelemetry?
OpenTelemetry? The in the middle of evolution, I would say.
Nice. Right. Uh, I think the last one. What's the one upcoming feature in Victoria Metrics or Victoria Logs that you are super excited about?
Yeah. During the last months, I was busy with VictoriaLogs mostly, with implementing querying capabilities in
Mm.
VictoriaLogs, and I'm very excited with the end results because I believe the query language at VictoriaLogs will become a standard
Wow.
for querying logs in the future. That's
Nice.
my no, not task, but I believe in that. And I would suggest you try just reading this LogSQL documentation for VictoriaLogs in order to feel the power of this query language, the simplicity and power of this query language, because there are a lot of query languages for logs uh, which are powerful, but not so easy to use for from the beginning. They have very steep learning curve, and
Mm.
I tried to make a query language which is easy to start using and
Mm.
at the same time it is very powerful. It allows you making collect different things, extracting different logs from unstructured logs, different fields from unstructured logs, and perform different stats calculations in the same query across different parts of logs, and that's great. I'm very
Awesome.
excited about this. What the end result of this log scale?
Awesome. Looking forward to trying out Victoria Logs.
Yeah,
I think
you
it's a
can try it right now.
beta.
And we are
Yeah.
going to make the 1.0 release in the coming months.
Awesome. Awesome. Yeah. Looking forward. Cool. Cool. All right. Thanks a lot, Alexander. Really appreciate. I know it was a long one. Super insightful discussion for me personally. I've used Victoria Metrics personally a lot at scale. Lived through other problems with other tools, and then having switched to Victoria Metrics has been super useful. So that was one of the main reasons I wanted to also talk to you. Thanks a lot for giving me time, and I hope this was also useful for a lot of listeners. Uh, that's it for the show. Thanks for joining. For audience, don't forget to subscribe, like, and share. And as always, keep learning.
Thanks for inviting for this interesting talk and for these interesting questions. It was joy to take part in this talk.
Awesome. Thanks for being the first guest. Really appreciate. All
Thanks.
right.
Bye.
Catch you soon. Cheers. Bye.